Ions. Today's lesson, we're going to look at ions. So, first of all, what is an ion? An ion is defined as a charged particle. So, let's write that down. An ion equals charged particle. Now, you'll notice I use the word particle as a general term because I cannot say a charged atom because atoms are not charged. That's why I've said a charged particle. Now, in order to form an ion, you either lose or gain electrons. So metals lose electrons to form. Now, if you lose your negative charge, you become positive. So a common misconception would be to think that by losing electrons, you're getting negative because you're losing. But no, you're losing your negativity, so you become positive. So metals will always lose electrons to form positive ions, which are called cations. Whereas non-metals gain electrons to form negative ions called anions. So that's the basic facts. Metals will lose electrons, so they're losing their negativity to become positive, and non-metals will gain negative electrons to form negative ions. So I could just edit this by saying gain electrons, plural. Now, if you gain one electron, you become a charge of -1. If you gain two, you become -2. If you lose one, you become +1. If you lose two, you become +2. So let's just see a few examples of metals and non-metals. So let's take sodium. It has 11 electrons. So its electronic configuration will be 2, 8, 1, like in the previous lesson. Now, the ultimate objective is to have a full outer shell. So to have a full outer shell, you could add 7, because the third shell is allowed to hold up to 8 electrons, or you could just lose 1. So you always go for the more favorable outcome. In this case, you lose 1 electron. Therefore, sodium will get a charge of +1, and it will be 2, 8 square brackets plus, because the 1 electron is gone. If we take aluminium, which is 13 electrons, it is 283. So to have a full outer shell, it can either gain 5 or lose 3. Once again, it's easier to lose 3 than to gain 5. So it therefore forms aluminium 3 plus square brackets 28 3 plus. You could write +3 if you want at GCSE. Now, these are metals. Metals lose electrons, and we call this oxidation. And an easy way to remember it is oil stands for oxidation is loss of electrons. Reduction, RIG. Reduction is gain of electrons, as you will see in a minute. So if we take, for example, chlorine, it has 17, so it is 287. Remember, 2 plus 8 plus 7 makes 17. Now, you either have to lose 7 or gain 1. In this instance, it's easier to gain 1 electron. So if you gain 1 negative, you become negative. The name for the nonmetal actually changes to a chloride ion, and it will therefore form 2, 8, 8 minus. One more example, let's take oxygen, which has 8 in total. So it's 2, 6. So once again, you have a choice of losing 6 or gaining 2. As I've mentioned, nonmetals gain electrons, so it gains 2. So it becomes an oxide ion, 2 minus, 2, 8. Now we call this reduction. And the way we remember it is RIG, which stands for reduction is gain of electrons. So in summary, you have oil RIG, you have the word cation, you can remember it as cats being good. So cats are good, so cations are positive. Anions is negative. Oil, oxidation is loss for the metals, and then Rig, reduction is gain for the non-metals. Your ultimate objective is to have 8, unless, say, you're lithium, which is just 2,1, because it has 3 electrons. Now, in this instance, it's just easy to lose 1, and you're left with 2, and 2 is a full outer shell. So it would form Li plus with just 2 electrons, and it would have lost its outer shell. Because it is in group 1, so it's actually behaving the same as sodium. It's losing 1 electron. Right, that is how ions are formed. So now we'll just have a look at a table of how you fill in the protons, neutrons, electrons for ions. Then you can practice the worksheet that will be attached. So we can save this. 1 second. Should be an option here. Yes, I found the option, save. It's a PDF. Okay, it's saved. I'm now going to clear it. And I'm going to go to a worksheet on ions. This is the worksheet. This is a worksheet for you to complete. Basically, you look at the charge, then you decide how many electrons you have. So for the sodium, for example, for the lithium, it'll be 2. When you get to stuff like the negative ones, say S2 minus, you would look at sulfur in the periodic table. So that's the first thing. You look at the periodic table. Let me get one up. There it is. Here it comes. So sulfur. It's the smaller number, 16. So 16. Now, it will have 16 protons because that is the atomic number. Now, electrons, because it's 2 minus, it has to have 2 more electrons than protons because the negative has to be bigger than the positive. Therefore, you're going to put 18 here. Now, if you would fill this in, the extra 2 electrons should be drawn with a dot if you've used crosses for the other ones, because it would come from a metal. So, for example, here, this sulfide ion would have 2, 8. So that makes 10. Now we need to get to 18, but it normally only has 16 electrons, but it's gained 2. So I'm actually going to put a dot here and a dot here, which makes 6 crosses and 2 dots. Then I'm going to put 2 minus here. Now you can put the dots together, but theoretically the x's would have been far apart at the start, and then the dots will come in. So that's how you draw them. You can practice that. Then if you look at a table, I'm just going to fill in 1 or 2 of these. Say you pick calcium. Is it an atom or an ion? Well, because of the charge, it's an ion. Its atomic number will be the same as the periodic table. Now, the periodic table shows that calcium is 20. So I'm going to stick to 20. The mass number 40 is given to us. The protons will be the same as the atomic number. Now, the electrons, because it's positive, will be 2 less. There'll be 18 because, whoops, put it in the wrong place. The electrons would be 18. You've lost 2 negatives, so you become +2. The neutrons will have to total to the mass number with the protons. So 20 plus what makes 40? Well, it's 20. Now, the electronic configuration based off the electrons will be 288, square brackets, 2 plus. Done. One extra example, say you're looking at this one. It looks a bit difficult. So there's not much information on it, except that it has lost 2 electrons to become 2. So it previously would have had to have 2 more electrons, which actually makes a total of 4, which means the proton number would also have been 4. So if you look at the periodic table, which proton number is 4? It happens to be beryllium. Beryllium is 4. So because the neutrons are 5, 4 plus 5 is 9. So the mass number is 9. The protons are 4, so the atomic number is 4. There's a charge, so it is an ion. It is in fact beryllium. Now the electrons are 2 less than the protons. In this case, it's only 2. So you put it 2. So you've lost 2 negative electrons, so the charge is now plus 2 because the positive outweighs the negative. So here you would put 2 plus, and if you want, you fill it in here. So 4 plus 5 is 9, so you would put 9 here for the mass number. And you can leave it like this. If you want, you can put 4 for the proton number, for the atomic number. So that is how you do ions. In the next lesson, we will look at ionic formulae. And that's the end of this lesson. Just practice the worksheet, and then we'll move on.